Hi, welcome back.
Hi.
Hello. So we're working on area, our first run on area. We did area a little bit, kind of at the beginning of the year. So we're just kind of bringing it back and reminding you guys. There's two new things to add about area. The area addition postulate, which basically says that I can take the areas of a bunch of different shapes and add them together to get a total area. The only thing I shouldn't do with this addition postulate is I shouldn't like put one on top of the other, okay? So I don't want to overlap one on top of the other, my shapes. Next to each other, that's fine. Hanging out in different sections, that's fine, but not on top of each other. The next new thing is down here, the area congruence postulate. Gentlemen, thank you. Area congruence postulate says that if I've got two shapes that are congruent, they're the same size and the same shape, then they have the same area because they're the same size. That should be a real kind of, well, duh moment. Okay? Duh, thank you. All right, let's talk area of parallelogram. Here's your formula. Formula says area is base times height. The base is any side of the parallelogram that you want to choose. The height is perpendicular to that base once you've chosen it. Perpendicular means 90 degrees, and so the height is 90 degrees to the base. Triangle. Triangle is just half a parallelogram, and so you're going to find your base, find your height, make sure it's 90 degrees to that base, and then divide that by 2. The thing is that with a triangle, the height is not just 90 degrees to the base, but also has to go through one of the corners. The corner that's not on the base that you've chosen. Okay? Make sense? All right. Rhombus or kite, these two shapes are related. This is a rhombus, all 4 sides congruent. This is a kite, one pair of sides congruent, the other pair of sides congruent. Here's your formula. D1, D2 does not stand for distance, does not stand for diameter. The D stands for diagonal, from one corner to the other corner. And I have 2 diagonals, and so those numbers at the end are counting. Diagonal number 1, diagonal number 2. Okay? Last formula we're playing with today, area of a trapezoid. The formula for area of a trapezoid, sir? Formula for area of a trapezoid tells you to take the area of the 2 bases. Those are the sides that are parallel to each other. Add them together. Then multiply it by the height and divide by 2. Okay? And so that's what we're going to be doing today. All right, here's our notes practice. I did some of these for you, but I'm starting with a blank paper, so you can tell me which ones you want to see start to finish, including the ones I already did, or the ones that I didn't do. Remember that this is for a completion grade. All right, let's look at the first section, 1 through 4. Which one would you like to see done? Number 2? Okay. Number 2, what kind of shape is it? All right, and in more general terms, it is a parallelogram. Because squares are parallelograms. What is the formula for area of a parallelogram? Go back to your notes. BH, base times height. All right, what is the base of this parallelogram? 1.6. What is the height of this parallelogram? 1.6. It has to be 90 degrees to the base. And so we're just going to substitute. Base is 1.6. Height is 1.6. And so using your calculators, there are several scattered throughout the room, so there should be one within arm's reach. Please tell me what 1.6 times 1.6 is. 2 point what? 2.86. We're going to Oh, 56, 2.56. We're going to round to the nearest tenth to make it 2.6. That's it. That's the area. Easy enough? We have to find the perimeter. How do you find the perimeter? Add all the sides up. See these little hash marks? What did that mean? Congruent. They're all equal. So I have 1.6 plus 1.6 plus. All right. So give me that 1.6 plus 1.6 plus 1. You could totally shortcut and do 1.6 times 4. 6.4. And we've answered all the questions on this one. Still in this section, is there another one that you'd like to see from this section? Maybe one that you got stuck on, you started, and you're like, I can't get it? Number 4? Okay. Number 4, started it and got a little stuck, yes? All right. What kind of shape is this? Parallelogram. Oof. What is the formula for area of a parallelogram? Base times height, yeah. What's the base? 30. What's the height? We don't know it's this dashed line right here. That 15 is for the measure of that side. Now if I look really close, and it's hard to see on the overhead, but if I look really closely, there's a 45 degrees right here. And if that's 45 degrees, then this angle right here is also 45 degrees. Which means this angle right here is also 45 degrees. And that's helpful because that makes this right triangle a 45, 45, 90 right triangle. Which means I don't have to use the Pythagorean theorem to find out the measure of missing sides. I can use some shortcuts. In a 45, 45, 90 right triangle, if I'm given the hypotenuse, in order to find the measure of one of the legs, I need to take the measure of the hypotenuse, divide it by 2, and then multiply it by the square root of 2. Don't overthink that. That's just what you do. We covered this back when we did right triangles, chapter 8, I think. And I forced you guys to try to find what the shortcut was on this. This was the shortcut. 2 months later, I give you the shortcut. You're like, doesn't do me any good now. It does do you good now because now we're going to use it. Now you have the shortcut. All right, so this is the hypotenuse, and I'm trying to go to one of the legs. So we're going to take 15, we're going to divide it by 2, and then we're going to multiply by square root 2. So in your calculators, go ahead and figure out what that number is and let me know. 10.6 you said? All right. So there's your height. So the area of this parallelogram is 30 times 10.6. So the area is 318. Several others of you, grab your calculators just to confirm. Make sure he didn't fat finger and do like 13 times 10.6. Yeah, confirmed. Okay, good. The hard part is deciding what shape you have and what information you have about the shape. Sometimes finding the information because it's not always given. Like the height here wasn't given, I had to find it. But once I have the information, you stick in the formula and it's done. Do you want to do another one from this section? Or are you feeling more comfortable? Number 3? Number 3. Okay. Yeah, we did this, I had this one written out for you, but I have a feeling that you want to see it because in reading that you weren't sure where I was getting some of the numbers, right? Yeah. All right, so what I did on this one was I noticed that this angle here is 60, which means this angle here is 60. This is a right triangle, which means this angle down here is 30. This is now a 30, 60, 90 right triangle. In a 30, 60, 90 right triangle, if I know the hypotenuse, in order to go to the smallest side, I'm going to take the hypotenuse and I'm going to divide it by 2. To find this medium side, which is the one I'm interested in because that's the height of my parallelogram, I'm going to take whatever this amount was and I'm going to multiply it by the square root of 3. That's your shortcut. Okay? So far so good? All right. So my hypotenuse is 24 because these little marks tell me that all these sides are the same measure. So hypotenuse to short side, divide by 2. 24 divided by 2 is 12. And then I'm going to multiply that by the square root of 3. I don't know, use your calculators. I can't do that one in my head. 12 times square root of 3. $20.78, so 20.8. All right. What kind of shape is this? Parallelogram. Look at the directions. What kind of shape is this? Parallelogram. What's the formula for area of a parallelogram? No, that is the Pythagorean theorem. We want base times height. What's the base of this parallelogram? Okay, and the height? 20.8. 24 times 20.8 is? 499.2. 499.2. All right. Feels okay on how we did this? This is about the trickiest that I can make it for you. Okay? Is give you some sort of special right triangle that then you have to fight with. All right, speaking of triangles, let's look at the next section, all about areas of triangles. Which one of these 4 would you like to see today? Number 5 and number 6. Okay, so we'll start with number 5 and we'll go to number 6. What kind of shape is it? Hi, Ethan, you'll want your pencil out copying. What was the shape? Triangle. What's formula for area of a triangle? 1/2 times base times height. What is the base of this triangle? Hi, focus up here, please. What is the base of this triangle? Okay. The shape that we're talking about is the shape that's kind of shaded a little bit, not the dotted shapes. Those dotted lines are extra information that could help. They're not actually part of the physical shape. So this would be the physical base of that physical triangle. So the base is 15. What's the height of my triangle? Yeah, but it's this one, right? But I don't know. Okay. I could use the Pythagorean theorem on this little triangle that's hanging out outside in order to find the measure of the height. Or I can super cheat and use the Pythagorean triples that I have memorized and go, this is a 3, 4, 5 right triangle, and so that height is 4. And I didn't have to use the Pythagorean theorem. This is not because I'm smart. This is because I've got numbers memorized, okay? Not smart, just memorized. You can use the Pythagorean theorem to help you. There's nothing wrong with Pythagorean theorem. Well, once you're done with Pythagorean theorem, you'll find that the height is 4. Like, go ahead and finish it out. Okay, just telling you right now, the height is 4. So what's the area of the triangle? I don't know, whatever you get when you do 1/2 times 15 times 4. You got a calculator, do it. 30, she says. Confirm it. Don't trust her because she's wearing glasses. I wear glasses too, and how many times do I mess up my numbers? Like all the time. 30. Had 2 people confirm. Sky, triple confirm it for us. Yeah? All right. We need to find the perimeter. In order to find the perimeter, I need the measure of this side. What can I use to find the measure of that side? It's not 15. What's this shape right here? What kind of triangle? A right triangle, which means I can use the Pythagorean theorem. Do I know the measure of this side? Yes, it's 4. I calculated that already. So once again, I can use Pythagorean theorem. A squared plus b squared equals c squared. Across from the right angle is always c. And so this time, I'm looking for the side c. 15 squared is 225. Oh, I was going to be way off. I know 14 squared though. Okay, add those together. 244. And then the square root of 244.
241.
Oh, 241. I misheard, I'm sorry. Okay, square root of 241. La sorda no oye. 15 point, we'll stop at 15.5. So now I have the measure of that side, and now I can add up all the measures, and I can give you a perimeter. Easy enough? Does anyone want to see any of the others in this section done, or is that more than enough for you to get the rest? That's enough? That's enough? ¿Es suficiente? Okay. Yes? Number 7. Sure, the one right under it that I didn't leave myself enough room to do. Got it. That's okay. I've got some scratch paper here. So I'm going to do number 7 on a piece of scratch paper because I didn't give myself space. Okay, so let me draw it. So this piece is 15, this piece is 11, this piece is 40. All right. Triangle. Area of a triangle is 1/2 times base times height. What is the base of this triangle? What is the height of this triangle? All right. So whatever that is, I'm guessing 230, no, 240. How wrong am I? 220. Perimeter. The 11 plus the 40 plus the measure of a side that I don't know. How do I find the measure of that side? Pythagorean theorem. This is across from the right angle, so it's C. No one cares where you put the other two sides. I'm going to need some serious help with numbers. This is like...
Oh, never mind.
Yes, we got to square them first, sweetheart. 11 squared is 121. Okay, and 40 squared? 160?
1,600.
Oh, 1,600. All right, add those together and I should get...
1720.
Okay, good. And then the square root, I'm not even going to try. I'm just going to wait. 41.5. So that goes here. And the perimeter is 92.5. Okay. I wrote down what you told me to write down. I like it. Question? All right. Feeling really comfortable with those triangles now? Okay, there's two others. Do you want me to walk through those two, or are you like, nah, we're good, on to the next thing? Number 6. Sure, once again, I don't think I left myself enough space, so I'm going to scribble down number 6 right here. Okay. Don't mind me as I draw out number 6. All right, there's number 6. This is the triangle that we want to find the area of. What's the formula for area of a triangle? 1/2 base times height. What is the base of this triangle? 22. Just the side that we're talking about the base of. What's the height? It's perpendicular to the base. This is the base. This is the side that's perpendicular to that. I know they're not touching. But if this were sitting on a table, the base would be sitting on the table, so you're looking at that line 90 degrees to the table, right? So this is the height. Whatever that number is. 176. The tricky one on this one is finding the perimeter. Because in order to get the perimeter, I need the measure of that side right there. Because I have this side and I have this side, but I have no idea what this one is. What kind of shape, though, do I have right here? A right triangle. Which means I can use what? Yep.
17.9.
So C is 17.9 when you do all that calculations?
Mm-hmm.
All right, I'm just going to go with it. She solved the Pythagorean theorem, guys.
But it's 73.9.
And I'm pretty sure she used a calculator to add those numbers.
And hopefully they're all
And hopefully they're all
right.
right. So guys, work on it, and then if any of those numbers are wrong, you yell at us. You did it already? All right, he did it too. He got the same numbers you did.
Oh.
Right on, so we confirmed it. Thank you. Do you need to see how to solve this one again, or are you okay with it? We're okay? All right. Let's go ahead and look into the next section, number 1, 2, or 3, your choice. 1, 2, or 3 on the next section, your choice. Number 3. What kind of shape? Rhombus. Or kite, you know, it could be a kite too, I don't really know. The good news is that they have the same formula for area. What is that?
Half times the diagonal
1/2 times diagonal 1 times diagonal 2. All right. Which one do you want to be diagonal 1? This one? Or this one? Which one is diagonal 1? This one? Or this other one? It doesn't matter, just pick one. Which one is diagonal 1? The short one or the long one? It doesn't matter, pick one. The short one. Okay, so here's diagonal 1. This little piece is 10. This piece over here is congruent, so it's also 10. The diagonal goes all the way across, corner to corner. So the measure of diagonal 1 is 20. 10 plus 10. That makes this over here diagonal 2. That piece is 20, which makes this piece 20, which makes the entire diagonal 2.
40.
So the area of this rhombus is 1/2 times the measure of diagonal 1 times the measure of diagonal 2. 400, she says. Easy peasy, huh? I want to skip the next 3 and go down to numbers 11 and 12 when you're ready. Unless anyone wants to see another one of these. Y'all want to see another one in this section? No? Okay. So your choice, 11 or 12 from the bottom. Gentlemen, please stop. Hi ladies, we're trying to decide which one of these two we want to do. 11 or 12? 12? 11? Because I did 11 already. Yeah, so I would rather do 12 than 11, but if you really want 11, I'll do 11.
Well, I thought it was for this one. I mean, no, I thought it was for this one.
This one.
It's 12 that you
This I did 11.
Okay, yeah.
Okay. Okay. Hi, gentlemen. Stay with us. What kind of shape?
Trapezoid.
Trapezoid. Formula for area of a trapezoid.
Half times base 1 plus base 2 times height.
1/2 times the bases added together times the height of the trapezoid. Remember that the bases are the two sides parallel to each other. So I'm going to add the two bases together. And then I'm going to get the height, which is perpendicular to the bases, and I'm going to multiply that. All right, substituting. What's 38 plus 12?
21?
Oh, 21. I'm so sorry. 21. 38 plus 21. 59? Okay. And then the height is 6. All right, put that in your calculator. Tell me what we get.
$177.
177. Boom, done. I'd like now to skip up to number 6. Because number 6 looks hard. Number 6. What kind of shape?
Height,
Rhombus or kite. What's the formula for area of a rhombus?
half times diagonal 1 times diagonal 2.
1/2 diagonal 1 times diagonal 2. We've been given the area, yes? Right here? Yes. What is diagonal 1? What is diagonal 1? Is it the x or is it the 22.5? It doesn't matter. The 22.5. Okay, I'm okay with that. Which makes this x the diagonal 2. All right. Now I'm going to substitute for what I know. And then I'm going to solve for the unknown. I have a fraction next to a number. I can either do that multiplication or I can get rid of the fraction. Which would you rather do? Get rid of the fraction. Okay, how do I get rid of the fraction? Multiply each side by 2. When I multiply each side by 2, that fraction disappears, and on this side I have a times 2. All right, I need help. 2 times 247.5, whatever that is. 4 something?
495.
495? I want to get x by itself. What should I do? Yeah, he wrote it out in the air. Divide by 22.5. So what do I get when you do 495? 22. We're done. Not that hard, huh? Okay. Feeling better with these?
Yeah.
All right.